Whoa, didn't know we were filming today.
Mystery Science Guy! Hi, I'm Mystery Science Guy, and I'll be introducing you to the wacky world of science, beginning with momentum. I'll be introducing you to it with these two meat sacks I found. Hold on a second. One second. Here they are. They're of relatively identical mass, and if you notice, they'll be running at identical speeds. When they hit each other, they should collide and stop where they stood. Alright, as you can see, they collided, and as I said, they stopped where they stood. That is according to the laws of momentum. I'll be demonstrating later on my chalkboard. You'll see. Watch. Did you see that? I saw that. What happened is that this bigger guy hit this smaller guy, and according to the laws of momentum, the little guy went further back. I'll explain later. You guys. Alright, so those were some pretty nifty demonstrations I showed you. I'm going to go back to the whiteboard, show you some how that all works out with some science, and you guys will learn a thing or two. Alright? Alright, I'm back, and I'm going to explain with my whiteboard what happened with those meat sacks earlier. Now, momentum is a conservable quantity as shown by the third formula on the whiteboard. Okay, so with the two meat sacks that were of identical mass and moving at identical velocities in opposite directions, they had opposite but equal in magnitude momentums, meaning when they collided, they canceled each other out. With the one with the lesser mass, what happened was that his momentum was lesser and opposite, and so he went further back. These are the laws of momentum. Okay, so now I'm going to demonstrate with this messed up bus about inelastic collisions. With inelastic collisions, you don't have a conservation of kinetic energy, but you do have momentum. Though kinetic energy is lost in the deformation process, as you can see with this bus. It's pretty messed up here. It's messed up because, it wasn't conserved. Alright, now I'm going to demonstrate with the... Nah, forget about it. Okay, did you see it? That was even crazier last time. This meat sack here ran to a bus. He ran to a bus. Okay, let's see what happened here. Is the bus has so much mass that for it to equate to the momentum he originally had, it only needs to move slightly. So slightly, it's imperceptible. It's crazy. Okay.
So you might have been thinking that there wasn't enough science in that video. So here you go.
Momentum is a vector quantity defined by the product of mass and velocity and denotes the difficulty with which a system is stopped, and conversely, the difficulty with which an object is brought to its current state.
Momentum is also a conserved quantity, meaning a system in which there exist two moving objects which collide will have equal total momentums before and after the collision.
So a system consisting of two objects of identical mass colliding with identical speeds in opposite directions will have no momentum after said collision, because the sum of the momentums of the two moving objects prior to the collision is zero.
A system consisting of two objects of different mass moving with identical speeds in opposite directions will result in the object of smaller mass moving with higher speed than the object of larger mass. Because in order for momentum after the collision to equal momentum before the collision, the object of smaller mass must have a greater momentum than the object of greater mass. This can only be achieved with greater velocity.
In addition, there exist two types of collisions, elastic and inelastic. In both, momentum is conserved, but in the latter, kinetic energy is not conserved, while it is in the former. During inelastic collision, kinetic energy is lost into forming one or both of the colliding objects in that system.
That would be pretty funny. What, Benny?
Wait, where's the balls?
Thanks, guys. Thanks.
Lights go out and I can't be saved. Tides that I tried to swim against.
I don't know who that was. I don't know who that was.
Down upon my knees. Oh, I beg and please, singing. Come out of things unsaid. Shoot an apple off my head.
Hi, I'm Mystery Science Guy. Now I'm going to be showing you some things about science, including what I'm about to teach you about momentum. Alright, you guys like that, boys?